Hello and welcome. We are going to be talking about identifying linear and non-linear functions and focusing on graphs and equations and how to determine when you look at a graph if it's linear or non-linear. And then also how, when you look at an equation, can you determine if it's linear or non-linear? So the first thing we're going to look at is we're going to look at graphs to decide how do we determine if it's linear or non-linear. So this is a really good example to kind of look at. So in this, for nonlinear graphs, this is a good example that goes with that. And then linear, we've got this one over here. So when we talk about linear, that word linear really sounds like line. And so anytime you think about linear, it means that it is a straight line. So that's where we have this function, this graph that shows that we have a straight line. So if we look at this linear graph here, we can see that from start, if we read this graph from left to right and we trace this line, we can see as we trace this line that it is increasing at a constant rate. And we can see that the graph results in a straight line. When we look at nonlinear over here, if we start at this point here, we can see as we go down, at this point right here, we change direction and then we start to increase. And then we stop at this point and we change direction again. And now we're decreasing. And then we change direction one more time, or two more times actually. We stop here, we're increasing to this point, but then we're decreasing and we end here. So there's a lot happening with this graph, a lot of changes in directions. This is going to show us this is not a constant rate. This is also going to show us that this is an example of a nonlinear function. It is not a straight line. When we go to the next example, the graph, this graph does show a function. Is the function linear or nonlinear? So we want to look at this graph and we want to read it from the furthest point, the starting point. We can see from here, we get to this point, we're increasing till about here. Then we start to kind of shift and we start decreasing until about this point. We shift again and we're increasing. And then now we are decreasing to this point. So again, there's a lot of changes in directions. This also shows us that this is not a straight line. So since it is not a straight line, that's where we would say that this function is nonlinear. Looking at this next example, is this function linear or nonlinear? If we read this from this point here to this point and we trace this line, we can see that this graph is going to show us a straight line. It is decreasing at a constant rate. Okay, and so the graph results in a straight line. And so we would say that this function is going to be considered linear. Now, as you work through this activity, these questions have the line drawn for us, but what happens if the line is not drawn for us? So if the line is not drawn for us, to determine this star over here, to determine whether the function is linear or non-linear, we want to see whether the points lie in a straight line. So what I'm going to do is I'm going to draw my straight line to see if all these points lie on the same line. And we can see from drawing this line that yes, they do lie on a straight line. And so we would say that this is going to be a linear function. But then in this case, we have these points and we could see, okay, I kind of start from this point here and I kind of increase and I kind of shift over. I drew the best straight line that I could, but we can see that this is not going to be a straight line. So determining if these points lie on the same line and it's a straight line, these points do not lie on a straight line. And so we would say this is going to be considered non-linear. Now that was pretty much the most of it with those graphs. Again, if the line is drawn for you, you can determine if it's a straight line or not a straight line. If the line is not drawn for you, there is a tool you can use and you can draw that line in and see if it's going to be on the same line. Now, if we switch to equations, the difference between graphs and equations is the graphs do not have the straight line, or they don't the graphs have the line drawn for you. The equations are not going to have the graphs unless you go through and graph the equations. There is a way that we can determine if the function, if the equation provided is linear or nonlinear. So if the equation can be written as y equals mx plus b, where m and b are constants or numbers, we also know this as slope-intercept form, okay? So slope-intercept form, if it can be written like that, then we would say, yes, it is linear. If it cannot be written in this form, we would say it's nonlinear. So in this case, the equation we have is y equals negative 8x minus 10. So we have y equals negative 8x. This negative 8 is in the place for our m. This negative 10, even though it's not plus b, we can rewrite this as y equals negative 8x plus a negative 10. These are the same equation. So since this can be written in the form of y equals mx plus b, we would say that this is an example of a linear function. Now, going to the next example we have is the function 8x plus 1 linear or nonlinear. Again, we want to make sure if it's linear that we can write it in slope-intercept form, which in this case we have 8, but then we have this exponent. This variable is written as an exponent, okay? There's really no way to change this unless we keep the exponent or we do the inverse operation, which is the square root. And so in this case, we would have this x as the this variable as the exponent. And so since it cannot be written in the form y equals mx plus b, that's where we would say that this is an example of a nonlinear function. A good thing to remember when you're determining if these equations are linear or nonlinear is if there is an exponent, if the variable has an exponent, if the variable is an exponent, if there is a radical, if there's a square root symbol, all of these are going to be indicators that this is not going to be a linear function. So the next example we're going to have is we have this equation y equals negative 6x squared. Okay, so we have this exponent here, minus 2x minus 7. So when we look at if we can write this as into y equals mx plus b format, again, we have this variable, okay? This exponent. This variable is raised to the second power. And so since we have this exponent here attached to the variable, that means that this is not going to be able to be written in y equals mx plus b format. So we would determine that this is going to be an example of a non-linear function. And then the last example that we have is the function y equals negative 2/9 minus 10/9 times the square root of x, linear or nonlinear. We have this radical, this variable's in the radical or the square root symbol, okay? So when we look at if we can write this in y equals mx plus b format, this square root symbol is not going to be able to be canceled or rearranged. It's going to be attached to that variable until we can solve for the variable. So in this case, since the variable is inside a radical, it cannot be written in the form y equals mx plus b. So this would be considered nonlinear. Again, a good way to remember this is if you see the variable has an exponent attached, if you see that the variable is the exponent, or if you see the radical or the square root symbol, that's going to tell you that this is not going to be able to be written in that slope-intercept format.